So I think there are 21 students. So let's wait for the 2 minutes. Then we start the session. Can you able to see my screen? Yes.
Yes, sir.
So let's begin. Uh, Unit 4, which is validity of assumptions. So we have already seen a lot of assumptions while modeling that models and everything, right? And we have seen certain assumptions. Maybe the data is normally distributed. Data is a whether there is a autocorrelation exist or maybe multicollinearity exist. Maybe that is all validity of assumptions. Okay, so we will deal more about the assumption part rather than modeling part. Okay. So what are the different criteria is there in the validity of assumptions? So we will see one by one. So the first one is we will see what is the agenda today. So what are the things we are going to study today in today's lecture? First is autocorrelation. What is autocorrelation? How that autocorrelation work? What is the applications of that autocorrelation, etc., etc. Then we have a detection of autocorrelation. So if in your data the autocorrelation exists, then what we can do it, and what could be the consequence? What will be effect of that? What will be the if it data if in your data the autocorrelation exists, then is that is there is any effect of like other components who is going to be get affected? Those things. So that is called consequences. Then if there is a autocorrelation, then we can use generalized least square estimator to estimate those parameters, because normal estimators we cannot go with the normal estimators like we use OLS, right? So one can go with the GLS. Then heteroscedasticity, then again same detection and their consequences. So again, if the heteroscedasticity exists, so we cannot perform our usual I can say modeling in terms of OLS. One can go with the WLS, which is weighted least square estimators. Then we have multicollinearity, and there is a what could be their consequence and etc. So few things I think I have not mentioned. Maybe regarding that plots. Okay, so the plots we can include in next slide, no problem. So what is an autocorrelation? So correlation means you are already knowing. Correlation means there is a strong relation between two linear variables. So if we have a two variable which is linearly related, then correlation is automatically, if there is correlation exists, then I can say, yeah, I can say strong relationship. I can say maybe the weak relationship, etc., etc. But autocorrelation means what? Basically, the autocorrelation is exist between the, if I consider the stock data, stock market data. stock market data. Okay, so if you just seen the stock market data, uh, I can say there is always a dependency between the data where whereas tomorrow's stock market and the previous market price may be the dependent. So I cannot say like today will be rate let's say 20% and next day it will be directly 100%. It's not like that. There will be slightly change in the data. There will be slightly change in the data. Means obvious. That means what is the correlation? What is autocorrelation? Autocorrelation is defined as a correlation between members of series of observation ordered in time. The very important, that means we are dealing with time series data. That means we are dealing with time series data. So as I mentioned, day to day wise, we have a data of a stock market. Like what is the first day? Like Monday, what was the stock market price? Tuesday, what was the stock market price, and so on, right? And based on that, one can get the autocorrelation whether the autocorrelation exists or not. Okay, so that is the one application where one can able to get understand what is the autocorrelation, and we can see the more examples maybe in the practical and maybe in the theory also. Okay, so how do you understand by autocorrelation? Means how do you know exactly the autocorrelation exists or not? Okay, so in the regression context, if I'm talking about in terms of regression context, the classical regression model assumes that the disturbance term. Now you know what is disturbance term, right? You know what is disturbance term. So disturbance term is your error term. The error term relating to any observation is not influenced by the disturbance terms relating to any other observations. That is, we assume symbolically ei and ej equal to 0. Okay, so if disturbance means the error term of one observation, like one series of observations, is not influencing by the error term of any other observations, so I can say that there will be no correlation exists. Means the ei and ej is 0, right? That means there is no relation exists. There will be no autocorrelation exists. But however, if there is a correlation between the disturbance term, obviously if there is some correlation, then expected value of ei and eeg is not equal to 0. We'll get some values. We'll get some values for all I is not equal to j, and this is called as autocorrelation. Okay, so what you have to do, you know how to find ei, you know how to find ej, right? ei is nothing but your expected value of like y minus y hat or something like that. Okay, so just remember that formula, and based on that you are calculating ei. Calculate ej means we have a given two series of the data and we are trying to obtain the, is there is a correlation, is there is a, means expected value means we are trying to find covariance, right? Because expected value of ei is 0, expected value of ej is 0, that is all assumption of your regression. मतलब क्या हो गया? Only remaining expected value of ei ej. So if this condition is not equal to 0, I can say that there is a autocorrelation exist in our data. Okay, so this is the mainly one thing that we are talking about. Then we'll see detection. How you'll detect whether the autocorrelation will be exist or not. So there are two tests. First one, Durbin-Watson D test, and second one is run test. Okay, this is I can say not in your syllabus. Sorry, this is not there. So second test is not there in your syllabus. So one may just note that this is not in your syllabus. So you have to just read. Means, but there are two tests exist. There are two tests exist. First one will be Durbin-Watson D statistics. Other one is a run test. Run test is a basically it's a non-parametric test which you will study in the paper 2, testing of hypothesis. Okay, but the procedure and everything will be the same. Okay, but in terms of regression, it is not there in your syllabus. So I have included both to introduce like one can able to use this as well as this. It's not like that you are not familiar with. No. It's not like that we have not seen that run test. Okay, so you must familiar with the run test. What is the run test? But mainly we are dealing with the Durbin-Watson D test. So what this Durbin-Watson D test does? Okay, so we will see that those tests how this particular test works. So if you just see this Durbin-Watson D test, Durbin-Watson have developed a test. Means this D test is developed by the Durbin and Watson. Have developed a test for detecting autocorrelation. The following are examinations under the Durbin-Watson D test. So consider this model. The regression model includes the intercept term. Okay. So to examine that Durbin-Watson D test, what are the conditions? So we need to understand the condition first. What is the condition? It has always intercept value. So there has to be the intercept term. Okay, one thing. That means in your model there has to be the intercept term, which is, so this this is nothing but your particular slope value, intercept value. This is your slope value, right? So in the model there has to be the intercept term. So model is there and beta naught is intercept and beta 1 is your slope value. Second one, explanatory variables, that is your x, which we are assuming here x or x1, are non-stochastic, means it should be not a random variable. That is fixed, means obvious, that means that is given, right? That means that is given. So that is, I think we are already dealing with the data where x will be the given data, so no problem. What is next? And the disturbance terms you are generated by first order auto regressive scheme. So ये थोड़ा सा concepts है. So what this concept says, see, we cannot use that, because we are talking about the disturbance terms. Okay, so when I talking about the error terms, I may use the first order auto regressive scheme. Now this is one type of scheme, one type of another model where we are discussing about the disturbance term. Okay, means I have to give another model which is dependent on EI, Okay, so what could be the model? What could be the model? So this is the model. What this model says, we have EI, right? EI is your error term, and this ET minus 1, or I can say ET or ET minus 1. So this ET minus 1, because this is a previous year data. This is again the previous observations I can, right? This observation, and you are forecasting the new observation. Let's say you are getting the idea about what could be my next day stock market price. So obvious I have to look the maybe the uh, last month price or last day price, right? So they are related. So this is the correlation, and this is the last error term plus some VT. Okay, so what this actually says, the error term ET is assumed to be the normally distributed. As I mentioned, this VT is a normally distributed. But here if you see the model, here, because there is autocorrelation exists. If there is autocorrelation exists, then one cannot use our usual model to like usual method to estimate the parameters. One may have to use the auto regressive model to get the parameter. Okay, to get the parameter. So that is the very important concept we can always go through. So in the model does not include the lagged value of the dependent variable as the so this is third assumption. This is the third assumption. What the assumption says? in your model, in your model, does not include the lagged value of dependent variable. Now what is the meaning of this? So lagged means the difference is there, means some difference will be exist. So if I'm considering different value of dependent variable, dependent means y, dependent means y, right? So there should not be lagged value of the dependent variable as one of the explanatory variable. Means there should not be like I can say the data which is automatically related. So this is my next assumption. There is no missing observation in the data. There is a no missing observation in the data. So if there is a missing observation, I know if there is missing, then what we do? Usually we replace by their mean, right? But uh, in autocorrelation, you assume that because these are the all assumptions. So if these assumptions are failed, then one may not apply the technique of auto-regressive concepts. Okay. Now we'll see the derivation part in the one note. Okay. Any query? Yes, any query? So we have seen assumptions so far. Okay. Now we'll see the remaining derivations, which is a small part that we will see in the notepad. Okay. So what this Durbin Watson disk test does? Let me see the chat box. Yeah, Sachin Viskarma, like the base year and current year, correct. Uh, Base year and current year, that means it's very, I think there is a lot many difference. So if you have to account current year, that is 2020, and the base year means 2019. So itna gap nahi hona chahiye. It will be like, it will be done weekly. Usually it is done by regularly, right? Per day. So in your per day data only there is autocorrelation exists. Like we can say weekly data. Weekly data there is autocorrelation exists, right? And lagged part. See, lagged means there should not be any difference exist. Like we know EI follows normal. EI follows normal. So if EI follows normal, that means that the expected value of ET will be 0, right? So expected value of ET is 0. That means the expected value of Y is also going to be 0. So if there is a lag value in the dependent variable, right? If there is a lagged value, means the expected value has to be 0. But if you will not let expected value is 0, then it may happen that there may be autocorrelation exists. Okay, because that is all your basic assumption. Your dependent variable like expected value of your Y is also follows normal. That is the condition we have seen in the regression, right? But if those conditions not satisfying, जैसे हम लोग Shapiro test करते थे ना, we check for Shapiro test whether Shapiro test will they be used for the basically dependent variable. So if the you can say it was not showing that whether it is normal or not, तो वो situation में auto correlation exist होता था. That's why the I can say that means there is a lagged value. There is a lagged value between the dependent. So that's why your it is coming like your Y is not follows normal. Is that okay? So we can see the more examples. You can just run. You can search in the Google, like, or we can when we deal with the actual practical problem, then we'll get the more clarity in that scenario. Okay. So let's see how this Durbin Watson did test works. Okay. So I hope we can able to see the unit 4, which is, I must say, validity of assumptions. So first one is Darwin Watson D statistics is defined as is defined as see the definition. D is equal to summation et minus 1 whole square upon upon summation et square. So D statistics is a totally based on your error term. So if you take a difference of your current error term with previous error term, square it, take summation, divide by summation of et square. Okay. So what this ratio says, it's a little bit dark pen, which is the ratio of sum of squared. So this is a sum of squared, right? Sum of squared difference in in successive residual, right? Residual is your error. Successive residual to residual residual sum of square. Residual sum of square. So you can see this is the difference of your difference of what? Successive residual. Successive मतलब क्या? 1 with 2 with 1, then 3 with 2. Means I am taking difference of successive. So if I have a data 1 to 3, so 2 का residual with difference with first one, then 3 का second one, fourth का 3 1. This is called successive residual. So sum of squared of difference of a successive residual to the residual sum of square. It means it's a residual sum of square. Now, what we do, we'll consider. I think this pen will be the fine because we can able to see clearly. You can use some light pen. Now consider. So I'm considering this term. Okay, in numerator part and trying to simplify that. Consider et minus 1 the whole square. What is this one? Apply usual formula. Summation et square minus 2 times summation et into et minus 1 plus summation et minus 1 का whole square. means applying the a minus b ka whole square and giving summation to each of the term. I may get this term, right? Now, if you see that, uh, assuming assuming see, there is a not much large difference between the et and et minus 1, right? And even if I take square, it's become like if I say my error term is 0.0003, right? That is my et term. And if you square it, it's become more I can say smaller, right? So that means there will be not much difference between summation of et square and summation of et minus 1 ka square. Okay, so their difference will be approximate same. So if their difference will be like, it's like one observations, because difference is very small. So what you will get it here? So I'm trying to replace this quantity or this quantity by this quantity. So your et minus 1 can be replaced by 80. Okay, तो कितना हो जाएगा यहाँ पे? Therefore, summation et minus 1 the whole square is equal to, so this is going to be et. You can substitute again here et. So it is going to be, should I write direct? So it is 2 times summation et square minus 2 times summation et into et minus 1. So when I just substitute this et minus 1 equal to et square, I may get 2 times et square. Now, therefore, d is equal to, I know the formula, this upon residual sum of square. So it is 2 times summation et square minus 2 times summation et into et minus 1 whole thing divided by summation et square. So what could be the next step? I can get cancel with the et square with et square. What is remaining? I can pull out 2 out. So 2 can pull out. It is going to be how much? This will get cancelled. So it is going to be 1 minus summation et into et minus 1 upon summation et ka whole square. I have skipped 1 2 steps. One can introduce more steps, like you can take first step will be 2 out, second step you divide by this term, so you may come directly with this steps, no problem. Okay, so you can show, if you want you can show all the steps, or if you don't want you can leave it, no problem. Now d is equal to 2 times 1 minus, I am assuming this whole quantity will be rho, this quantity will be rho. What is the rho now here? That rho is going to be, where rho is correlation, it's a correlation coefficient between et and et minus, and it is called as, sample first order coefficient of autocorrelation. It is called as sample first order autocorrelation. When, now I'm putting some condition on that. When rho is not known, rho is not known. So generally, if you know, if something is not uh, like not given, so we replace by their estimates. So we replace rho by rho hat, right? Therefore, d is equal to 2 times 1 minus rho hat. Now, you know that particular row hat is generally, what is that? It's a it's a correlation. It's a correlation. You know, it is correlation, right? So if there is correlation, that means we are knowing everything, right? We are knowing everything. So correlation means when I know the correlation means it can be zero. Correlation lies between minus 1 to plus 1. See, I understood what is the meaning of rho hat. So correlation lies between minus 1 to plus 1. So if I'm knowing the correlation lies between minus 1 to plus 1, I may get the idea about my D. There is no problem at all, right? So when rho hat is equal to 0, what happened? When rho is equal to 0, I may get, that is, D is equal to 2, right? That means there is no auto correlation. Are you getting me? Rho 0 matlab kya? What is the meaning of rho 0? No correlation exists. So same interpretation for D is equal to 2 is also no autocorrelation exists. So remember, whenever in objective question asked D is equal to 2, interpret what? That means there is no autocorrelation. तो जैसे हमारा रेंज रो का होता था, वैसे रेंज हमारा D का होगा. Now what happened? When rho is equal to, let's say, I can say 1. That means what? If rho is equal to 1, that means it is going to be 0. That means there is perfect correlation. Sorry, perfect, I can say positive correlation, because positive has to become perfect positive correlation, right? There is a perfect positive correlation. Similarly, when rho hat is equal to minus 1, that is, D is going to be, I think, minus 1, that means it is going to be 1 minus of minus plus 2, so 2 into 2 is 4. That means there is perfect, there is perfect, but in this situation it is going to be negative correlation. There is negative correlation. Yes, go through entire thing, go to entire thing. If you have any query, let me discuss. Yes, let me know. Let me know if you have any query. Try to understand conceptual thing.
सर
बोलिए।
सर आपने वो पूरे टर्म को रो कैसे कंसिडर किया?
पूरे टाइम को रो कैसे कंसिडर किया?
यस सर।
थिंक लिटिल बिट। क्या है वो टर्म, क्या है मेरा? व्हाट इज ईटी? व्हाट इज ईटी?
एरर टर्म।
हम्म। हाउ डू यू कैलकुलेट? ईटी का फॉर्मूला क्या है? यस एनीवन?
yi minus y hat.
yi minus y hat, right? So when you substitute the values of et term here, क्या मिलेगा? Is that correlation? कोरिलेशन मिलता है कि नहीं मिलता है? It's a covariance between, if you remember, it's a covariance between something variance, na? There are different form of the correlation. There are different form of the correlation.
यस सर।
Hmm. So that is, so that's why I have considered, because the numerator is a covariance term, and below that we have a variance term. Okay, one can consider the row will be that particular term, because it's a giving the relation, it's giving the relation between the uh, current term with the previous term. Et and et minus 1 ना relation बता रहा है वो. Yes, anyone starting from D? Any question till here? So what is your analysis here? What happened? So one may get the values of D, which can be positive, which can be negative, which contain no correlation also, right? So one may define the criteria for D when when D lies between in some range. D lies between some range. Okay. So uh, if I'm saying, let's say my D lies between, okay, I can say, let's say, hence, hence, if D is closer to 0, if my this D is closer to 0, what I can conclude? There is greater evidence, there is greater evidence of positive correlation, right? Similarly, if D is closer to 4, D is closer to 4, there is there is evidence of negative correlation. So I may define some range here. So what happened here? Durbin Watson have successfully derived some uh, lower boundary and upper boundary, right? Which can be done based on some limitations. So one can give their lower bound as well as upper bound. So Durbin Watson have have successfully successfully derived lower bound DL, DL and upper bound DU. So they have defined DL and they have defined DU. So that so that conclusion can be made about about the presence of positive or negative or no auto correlation, no auto correlation, depending whether depending whether calculated D lies outside DL and DU. So it's based on your DL and DU. So if you calculated D, if it is lying outside that DL DU, so one can put some conclusion based on that. Okay. So what could be the conclusion here? So if I'm considering here, let's say if, so let's try to understand how we can put the conclusion. If 0 is less than D less than equal to DL, So what could be decision? What could be decision? Decision is positive autocorrelation. Right or wrong? What happen if my D, if my, understand the problem. If DL, that's a lower value, less than D, less than equal to DU, then what is your conclusion? What is your conclusion? You might be or not knowing the conclusion because we didn't define the values of DL and DU, right? So in this case, your decision is going to be no correlation. Because what I mentioned here, the D lies outside this DL and DU. Okay, so this D value can be, it can be outside of D like above 4, greater than 4. So the conclusion means, the giving conclusion is like no, it's not no correlation, it's no decision. It's no decision. That is like no correlation means it's not correlation. There is no decision because we don't know about decision. No decision. What happens if my du, this is a lower boundary, less than d, less than equal to 4 minus du? I may use capital Du or I can use a small. Means it's upper values. It's upper values. Anyways, if my upper value is let's say 2, so I may get some values of d. I may get some values of 2, right? So what could be the conclusion? What could be the decision? So decision is either we will get no positive or I can say negative. Negative autocorrelation. Try to understand this interpretation because this interpretation based on the data. Okay, we are not like we are just considering the random things and based on that we are just concluding. Again, if 4 minus du is lesser than d, lesser than equal to 4 minus dl, what could be decision? Again, there is no decision. How you decide whether there will be decision or not? So if we complete this, then we can able to see. If 4dl is less than d, less than 4, what could be decision? Again, there is a negative autocorrelation. Now everybody just think whether you can uh, able to say this, whether that particular conclusion which I am writing, is that right or wrong? Let me know. Yes. How do you decide? How do you decide? See, if I'm just assuming this value, let's say DL is some value. DL is some value, let's say, for example, my DK value is, let's say, 2. So what will be the range of 2? 2 less than D less than 4. Right? 2 is less than D less than 4. Where it is lying? Which condition satisfies? Is this condition satisfies? That means there is a negative correlation. There is a negative correlation. What about this condition? If you consider upper value, which is, let's say, 10, and lower value is 2, so is this condition satisfying? This is 10, this is 2. So 10 लिया तो क्या होता है? -2. Upper value is, this is 2 you assume, which is 2. So no condition satisfying. That means I cannot put any decision based on my D. What about here? Take du ka any value. Let's consider my upper value is for example let's say 2 du. Is this satisfying? So 2 is less than D less than 2. That means we will get D is equal to 2. D is equal to, that means there is no autocorrelation. That means it depends on the du upper value. It depends on the upper value. So what could be the upper value? So it depends on the du value. Okay, so we need to take a decision based on du. We need to take a decision based on du and dl. But we are checking these values only. यही condition हम लोग check कर रहे हैं. Based on this condition, we are checking whether there is a autocorrelation exist or not. Okay, so when you have given actual du and dl, based on that you may see these conditions, and according to this condition you may write down the output. Okay, so this is just I want to just tell you. If you have any query, let me know. If du and dl are equal in the sense 2, let's say 2. So if du dl are equal, let's say 2, then that is equivalent to d, which is 2. That means there is no autocorrelation. If du dl are equal to 0, then there is perfect correlation. So if you're talking about du dl are equal, see, that is based on the data. That is based on the data. So one can see that how this du dl works, and then accordingly based on that you have to make decision. So if your D lies outside DL du, that means I may say there will be no conclusion. There may be no conclusion. It may happen. Okay, and then based on that you can put the conclusion. So this is some criteria. This is some criteria where one can able to see the values, and based on their values one can conclude the results. Okay, there is a positive, but generally you make sure that we are using uh, this conclusion only. Okay, because this is important. This is important, and based on that one can give the conclusion in the case of lower and upper values. Yes, any question? So what happened? What could be the consequences of that particular autocorrelation? So if the autocorrelation exists, what could be the consequences of that autocorrelation? Okay. So in presence of autocorrelation, the OLS estimators are linear. So if there is autocorrelation exists, you know that the OLS estimators are linear, unbiased, as well as consistent. You know that what is the concept of a consistent and everything, right? Asymptotically normally distributed, but they are no longer efficient. That is, their variances are not minimum. Their variances are not minimum because there is a presence of autocorrelation. Okay, so this is the first case when the uh, autocorrelation exists. So others all estimator like condition satisfying, whether your estimator is good, like unbiased, consistent, asymptotically normally distributed, but they are not, no longer it is efficient. Means variances are not minimum. Okay, this is the one I can say consequence. Other is confidence intervals are likely to be wider, right? The confidence interval is, it's not like very narrow, it is wider and wider. The variances are not minimum. That means we don't know, we cannot say anything like whether it is appropriate or not. That's why the confidence intervals are likely to be wider. Then we are likely to declare that coefficient statistically insignificant, even it may be statistically significant. So it may be declared that, see, if your confidence intervals are likely to be wider, so I may say that like your even your coefficients are insignificant, but still I am saying it is statistically significant, because what is the concept of confidence interval says, if your confidence intervals are wider, I may say that my that population parameter is lies between that interval, right? That means you are going to accept h naught. अगर मेरा कोई इंटरवल है, ठीक है, वो इंटरवल में अगर मेरा पॉपुलेशन मीन लाइज करता है, तो हम लोग क्या करते हैं, वी एक्सेप्ट एच नॉट. दिस इज वेरी स्मॉल कंसेप्ट, वेरी स्मॉल कंसेप्ट. तो अगर इंटरवल है, अगर वो इंटरवल में मेरा पॉपुलेशन मीन लाइज करता है, in that scenario I am going to accept h naught. Accept h naught का मतलब क्या होता है, you are you are saying that it is insignificant, even it is significant, because of we have a wider interval. Okay, so these are the few consequences when there is a presence of autocorrelation. Therefore, in the presence of autocorrelation, we obtain generalized least square estimate. So that OLS estimator fails because of these criteria. That's why we go for the generalized least square estimate. And derivation part again we will see the note. Yeah, let me know if you have any questions first of all in the presence of autocorrelation. Yes, tell me any question. No question. Shall we proceed? Okay, let's proceed. So now we deal with generalized least square estimate. So the next is generalized least square estimators. That is called as GLS. We can call as GLS. generalized least square estimator. So in this scenario, what we do, we'll consider uh, what is called we consider one explanatory regression model. Okay? Consider one variable explanatory model. I can say regression model. Oh. So what one explanatory model says, yt is equal to beta naught plus beta 1 xt plus some error term, right? Plus some error term. And where where you are knowing everything, what is your beta naught, beta 1, what is your et, right? So I'm not writing anything here, right? Because it is assumed to be unknowing. We assume that we assume that the term et, the term et, this et error term are generated by, see the concept, by the first auto regressive scheme, that is et is equal to row time et minus 1 plus vt, and where even now you're also knowing what is the row and everything. Still I'm writing here because it is something new, where rho is the autocorrelation coefficient and rho is the sample first order coefficient of autocorrelation. So rho is called as the autocorrelation coefficient and rho is the sample first order coefficient of autocorrelation. And what is your VT term? VT is error term. VT is error term. Now we'll assume the first case. So case first. What is first case says here? Just a minute. The first case says row is known. So I'm assuming my row is known. What happens if row is known? If the row is known, What could be that? Yt is equal to beta naught plus beta 1 xt plus et. I have this expression. Call this as 1. Can I get previous year data? So yt minus 1 is equal to beta naught plus beta 1 xt minus 1 plus et minus 1, right? This is the last year data, previous observations. If I multiply equation number 2 by row, what happened? Multiplying or multiply equation number 2 by row, what happened? Row yt minus 1 is equal to row time beta naught plus row time beta 1 xt minus 1 plus row time et minus 1. Say this is 3. Now what happened? Do 1 minus 3. 1 minus 3. क्या मिलेगा? 1 is this one. 1 is this one. First expression. Subtract with 3. क्या मिलेगा? Yt minus row time yt minus 1 equal to this minus this. So I can take beta naught out. Beta naught 1 minus row. Similarly here also, what I can take out, it is beta 1. So it is a beta 1. It is beta 1 beta 1 xt and row time xt minus 1. Is that right? Xt minus row time xt minus 1 plus et minus row time et minus 1. Is that right? Yes? Anyone? Now I'm assuming this quantity is going to be yt star. So yt star is equal to beta naught star plus beta 1 star xt star plus et, and saying this expression is A. So can you think of this expression? This is become nothing but your, it's look like your normal OLS. It's look like your normal MLR, SLR, right? But here, if you see YT, what will be YT? Where YT star is equal to YT minus row time YT minus 1. What will be beta naught? Beta naught star is equal to beta naught.
Beta naught 1 minus rho.
Yes. And similarly, beta 1 star is equal to beta 1 and xt star is equal to xt minus row time xt minus 1, and et I can take et will be as it is. Et is going to be, I can use et star also, no problem. Okay, but one can use et also, or because it should not be match, right? We can use some other term. Uh, is that vt we have not used? Okay, let's see. Let's say this is vt. Let's say this term is vt. This is your VT. So your VT is going to be ET minus rho time ET minus 1. And the equation A is called as generalized or quasi differential equation. Quasi differential or difference equation. Difference equation. Let me check whether it is differential or difference. Better. And here the error term VT satisfy satisfies the understand usual OLS. You know what is OLS? Assumption. Usual OLS assumption, that is expected value of VT is equal to 0 and variance of VT is equal to variance of VT is constant. So if the expected value is 0, what could be the expected value of Vt into Vt minus 1? Is that going to be 0? Therefore, we can apply OLS method to transform variable. So we can apply, now I know that your Vt follows I can say assumption which satisfy the condition of OLS. One may transform their variable like your dependent and independent variable, and one can apply OLS and get the estimator of beta naught and beta 1 star. So that is your YT star and XT star and obtain the estimators of beta naught star and beta 1 star, which are which are so you've studied this term, best linear unbiased estimator, right, which is called blue. Therefore GLS is nothing but OLS and applied it to Validity to transform variable which satisfies classical classical assumption of linear linear regression model. What is the linear regression model? One can get the beta naught star. So this you can apply and you can get these values. I hope you know this because your internal is very near. So you should know what could be the beta naught, what could be the beta one, everything. And you may have the beta one also, which was as per my concern x1 xi star yi star whole thing upon summation xi star square, where where xi star is nothing but xi star minus x bar star t, and yi star is nothing but yi star minus y bar t. So this is the way, this is called case one. So if your row is, I think this is the row is known. If row is known, one may one may use this technique, and I think this technique is similar to OLS. One can use OLS and they can proceed entire conceptual thing like OLS, and they can get the values of beta naught and beta 1. So one can write this directly because we are already done the paper 2, unit 2, and one may write the values of beta naught, beta 1 directly. Yes, any question? You know. First you can
जब
start.
तक लेक्चर है
Yes, बेटा बोलिए. बोलिए, any guess, any difficulty, any query. So you may go through this. Like you define the model, define autoregressive model. This is important. And then if row is known, the row is known, I can do any transformation. तो ये मॉडल हो गया, ये उसका सक्सेसिव मॉडल हो गया, मीन्स t minus 1 multiplied by row and subtract 1 minus 3, that become equivalent to your normal model like OLS model, and this is also known as QZ difference equation or generalized difference equation. And once you get that, I know this VT is satisfying the condition of your normal, that means it is OLS. Once it is OLS, I can do the transformation on XT and XT star, and I can get the values of beta naught, beta 1, which is also best linear unbiased estimator. What is the best linear unbiased estimator? Yes, anyone? What is blue?
minimum variance.
Only minimum variance. Yes, only minimum variance. So best linear unbiased estimator is estimator where we are getting the among all estimators we must have unbiased estimator. See, those all are unbiased. Those all are unbiased as well as variance is minimum. So it's not like that. It's not like that that the estimator which has minimum variance but it is biased. It may happen also, right? That estimator is like unbiased, but it has a minimum. It has minimum variance. So remember, blue means it's a best linear unbiased estimator. Unbiased means among all the unbiased estimator, among all the unbiased estimator, we should get minimum variance, and therefore that particular estimator is known as best linear unbiased estimator. Okay, so it is not only talking about variance, here also talking about the unbiasedness. So we must have unbiased, and based on that whichever estimator having the less variance, then it is called as blue. So this is the case 1. Now we'll move to the case 2. Rho is unknown. What happens if rho is unknown? Second case. Rho is unknown. If the rho is unknown, I will say if rho is unknown, it is estimated using its using its relation using its relation in terms of Darwin, Watson, D statistics. Therefore, Darwin, Watson, D test is given as D is equal to 2 times 1 minus rho, and therefore rho hat is equal to 1 minus D by 2. However, it should be noted that relationship may not hold for small samples. So make sure that when your row is unknown, then task is very simple. We are going to use Durbin Watson D statistics, and I can get the values of row using that relation. However, it should be noted that the relation may not be hold for the small sample. However, relation will not hold for small samples. So if we have the small samples, I may not use this relation. I may use for the run test. Okay, I may use for the run test, which maybe you are going to study it in the another paper. But in terms of regression, this much is there is in your syllabus. Yes. Now any question? Let me know any questions if you have. Interview in the maybe the last session and many more sessions, right? Where we are discussed what is the heteroscedasticity and how it is present. How do you know whether heteroscedasticity is present? How you can remove it? The removal part is not there in a syllabus. Only to checking whether it is exist or not, and if it is there, then how you tackle the problem, right? Those things we have already seen in the practical. So what is heteroscedasticity? Means that uh, as we know the classical linear regression model, the variances for each disturbance term for the given values of explanatory variable is same, right? For the given the values of explanatory variables are same and equal to sigma square, then the conditional variance of y given x is remains the same regardless of the values taken by the variable is called homoscedasticity. Means that if I am obtaining the conditional variance of y given x, this is equivalent to your variance of x. If this situation arises, that means that your data is homoscedasticity. But if it is not, then it is called heteroscedasticity. But variance of y is not same, then it is called heteroscedasticity. I told you, na, when conditional variance, conditional variance, you have already seen what is the conditional variance, right? I think आपका पेपर वन में सब वही सब पढ़ते हैं ना, बाई वेरिएबल सब किधर है? No, it's not there. Paper one or two, I don't know. But you understood what is a conditional variance. Conditional variance means you know the distribution of y given x, and then based on that one can find conditional mean conditional variance. So the conditional variance of y given x will be equal to variance of x, then it is called homoscedasticity. But if it is not, then it is going to be like heteroscedasticity will be present. So the conditional variance of y is basically uh, conditional variance of y is not equal to sigma square. That means it is not equal to, that means I can say it is not same for all the data. Then I will say heteroscedasticity will be present. This is one example. In regressions, saving of the incomes. Understand? Huh? Saving of the incomes. So I'm talking about in regression terms, saving of income. As income increases, saving also increases. Is that true? ट्रू है क्या नहीं? जैसे आपका इनकम बढ़ेगा तो आपका सेविंग भी तो बढ़ेगा. So if the variance of saving remains same at all level of income, then it is an example of homoscedasticity. Are you getting my point? तो जैसे जैसे आपका इनकम बढ़ रहा है आपका सेविंग भी बढ़ रहा है, मतलब आपका जो वेरिएंस है वो सेम है, मतलब it is homoscedasticity. But if observe that higher income families on an average save more than lower income families, then variability in saving is more for the higher income families than lower income families. It indicates there is heteroscedasticity present. Are you getting me? Are you getting me or not? तो क्या होता है, हायर इनकम पीपल विल सेव मोर, higher income people will save more as compared to lower income people. Obvious saving because lower income family obvious having the lower income, so they will save according to their proportion, according to their proportion. That means their, I will say this is not maybe not appropriate because we are comparing with the like a very big person with the high person. So it may happen that obvious there will be heteroscedasticity present. But if I take the previous like saving of the income example, if the income increases and saving also increases, So the variance of saving remains same, then he called it is homo. But if the variance of saving will be like up and down, then I will say it is heteroscedastically present. So ऐसा आप consider कर सकते हो. One way you can consider like that. Then we go for the detection, and in detection we have a Bruce Pagan Godfrey test. That is, we have already seen that BP Godfrey test. I think the BP test we are already working on that. And then Spearman ranks correlation test. Again, this is the, I can say, not compulsory test. So in your syllabus we have only this first one test. Okay, there are two methods, but we are taking only the first method because this is your out of syllabus. Okay, and we'll see the derivation part in the notepad. Okay, so let me have any questions. No question. So you start preparing for the, like, I will upload this video. Okay, you start maybe giving some time for maybe some time for unit 4, but mainly you focus on your for internal first because that is important. Okay, and then we'll see what else we can do. No problem.